Welcome back. Today we're looking after the Tektronix 464. It generally works, but it's got a few scratchy pots. The persistence pot is scratchy. It's an analog storage scope, and the first channel doesn't work anymore. Interestingly, if I check the trigger view of channel 1, it's about half the voltage, so either we have a problem, something is fried at the input. It was working some time ago. Either something is fried on the input, or a switch is faulty, or yeah, one of these switches, who knows. I think the preamp works. It's somewhere deeper into the machine. It just doesn't display on the first channel. Second channel works fine. However, the trigger is a bit weird, so maybe a voltage issue somewhere. I had it for a long time, and it served me well. I got it with a few issues. I can't remember what it was. I think the mains capacitor was blown, short circuit or something like that. It's a nice scope. It's again, it's an analog storage display like the one here in the Altec 727. Just a variable persistence tube. That's the next one we're going to look after, because we have that display issue there as well. Okay, let's take the cover off and have a look inside. It actually can run from DC, 12 to 15 volt, 8 amps. Well, it's Tektronix. To take it apart, I think it's these 4 screws, and then that back plastic frame comes off. Something like that. I can't remember it. It's such a long time ago, but something like that is gonna happen. Let me try to get it apart. So here we have it out. Yeah, it was the frame, then pull it out. This is the reset button, and I can't hear the switch flicking. I think that's the switch, I think, and it doesn't flick, so you can't reset the screen. And the pot is scratchy as well. So is this one. Both pots are scratchy. I don't know how I get there. You can see I did that's an older emergency repair, because one of the caps shorted out, because I didn't have this style caps here. These are pretty old electrolytics made in a long time ago, most likely. Can't really see it, but it's pretty long time ago. The problem with Tektronix is they don't put dates on their components. Most of the components are actually labeled in a Tektronix fashion, but we have a date code here which is 7816. That's probably week 16, 78. That's most likely when the scope was made. So it's not so old. I thought it was older. Anyway, let's turn it around and look at the input circuitry. So that's the input side, and we have a problem on this channel here. I think it works to an extent here, but we don't know exactly how far. So can be anything. Could be contact, could be switch, because all these switches are having long studs going to the back somewhere. I think the plan of attack is checking voltages first, and see if the power supplies are good, and then we go from there, because it's very likely that another capacitor died. Wouldn't be surprising, because when I got it, probably about 20 years ago, yeah, maybe 20 years ago, about that, it didn't work, and because that one of the caps were completely shorted. And the same with the 465. If you watch one of my older videos, the trigger circuitry repaired itself. It's working now. I think it was a switch. That switch, I just flicked the switch a few times, and it started working again. It was probably dirt in the switch. Anyway, yeah, we need to check out what's going on here. I pulled a drawing. and then we inject the same signal on both channels and just go through and see where we lose the signal. That's the plan for now. Obviously checking the voltages first, but I need a drawing to see where we're gonna check all these voltages, because there's not much writing on the board itself. We'll get there. Alright, we checked all the voltages, at least the ones we can find, and they're all good. I didn't check for ripple, but they're okay so far. So we shouldn't have a supply issue. I think just the performance check is about 10 pages. Looking for the drawing and just find a common point in the signal part where you can compare right and left, and then we just follow along the signal part and see where the signal disappears. We know it's going somewhere because I can see the trigger point. The trigger point output is about here, so maybe the trigger circuitry works, or the trigger signal conditioning works somehow, but the signal part itself doesn't work. I don't know, we'll find out. I know it's hard to see. This is actually coming from the input, and this is the coupling to the board itself, and we've got the same value in both channels. Settings are the same on both channels, 2 volts per division. Now it's back. The problem is back. There is a problem somewhere. I don't know what it is. Hard to see. Let's turn the light off. Now it's fixed itself. Huh? Ah, it's a dumb light. This freaking light here. Holy cow. Take the light away. Look at that. This is awful, isn't it? It's a fluorescent light. Oh, well, yeah, sometimes the obvious things are... Now I remember that. I repaired another scope and had the same issue. Let's check what's coming out here. No, there is some jitter, but we are 5 millivolts. That's 2.5 millivolts here and 2.5 millivolts here. So we're good from here. Problem is further back. I need to turn that light back on because otherwise I can't see anything here. This is so dark. It's just amazing how much interference this thing produces. Anyway, let me check further back and we'll get to it now. Well, so what we know right now is this seems to be all okay. We get a signal here and it's the same signal on both channels. So it's probably on the vertical amplifier, because the beam finder doesn't display the second trace either. So yeah, we know this part is working, so we're going to turn it around and look at the underside, find out where this one's going. I checked it with the drawing. It all looks good so far. There's no excessive DC on it. So we'll carry on searching. We're going to find it somewhere. Okay, I think we can narrow it down to the either vertical driver or output board, because if we use the beam finder you can see that bar at the bottom, and it's definitely channel 1, because channel 2 is the one with the sine wave. So maybe we just got a position thing issue. I can't really, position doesn't matter. So I think that's our problem. So we have a negative offset there, but the voltages coming out of the main amplifier were all the same. So it's gonna be somewhere where the signals are coming together. We need to figure out where that happens. We know the signal part is good to the end of the board. All we need to find is where is it actually going, and we'll find that out in a minute. So we checked the amplifier, both amplifiers have about -6 volt DC here, and that's channel 1 visible signal out is exactly the same as 2. That's weird. As soon as I turn position down, gain, balance, position is here. So this, because that's, don't know what that is, but the position has an impact on this output here, on this one or on this one, it depends, because that's applying a voltage here. So maybe we got an issue on this circuitry here, probably. Right, let's figure that out. The reason for thinking that is because the beam finder shows a trace. So there is a beam, but the beam is miles out. Let's have a little look to that amplifier board. Maybe there is a problem. We're actually a bit closer now. On the channel 2 we have 2.8 on this rail here. I found those resistors. However, on channel 1 we have 6 point something volts here, and I think this is the offset circuitry, which puts the DC offset onto the output signal basically. So we need to figure out why this voltage is so high. Probably what's gonna do something, it's these two transistors do something here. It's supposed to be 5.7 volts here, so let's measure those. I don't know if the mouse pointer is visible here. We saw the signal here, but we could have one of these transistors here leaking, and that would actually pull that to the side. Or this pot is faulty, because that's -8, and that if the pot is faulty or the transistor is faulty, it pulls it into one direction. But we have a positive voltage here, so that's 7.8 here. Either transistor or that RC combination may have an issue. Let's go this way, let's find this one. Well, it was a bit tricky. That's coming from the other board. I was always under the impression that the other board is causing the problem, because my voltage was about 5 volts here rather than 2.8. So I checked the voltages here and they were about okay-ish, but a bit too low. So I swapped these two transistors and the problem moved down here. So Q304 was actually faulty. One leg has no conductivity. I think it's this end, which doesn't work at all. The problem is it's got a Tektronix number on it, so I'll probably try a 3904 or something like that just to see if it works. Yeah, because we were always looking in this area, because these are actually pulling the voltage down. The pot is scratchy. That was another one, so the supply, it's plus 0.7 volt bias or whatever. But that wasn't the problem. The problem was actually that when I pulled this one, it disappeared. The voltage disappeared. What I didn't think about was that there is a negative voltage applied on this widest transistor. So this is pulled down from this transistor, and if this is faulty, it's not working. So I think it's a small signal transistor. Voltage wise, it's not a lot. So we try a 3904. It's a PNP, and is it? Yes. Let's try it. And we are looking for this one here, which is a 2N4258. Of course, it's a weird transistor. I don't know if it's visible. It says 12 volts, 50 milliamps, 700 megahertz. It's a switching transistor, and the BSX36 is an equivalent. The 3904 is certainly not, because that only does at 60 volt, 200 milliamps, 250 megahertz. Well, we need to find something else. Well, sort of success. The pot is still scratchy, but we have both channels working. We substituted it with a BF324, which is 450 megahertz. Yeah, it's not ideal, but you know, better than nothing. Let's see if that. It's a bit washy on this channel. Yeah. It looks a bit mushy, but maybe that's just the trigger level. Don't know. Yeah, at least it's working. You got both channels working, and they, let's see, they display about the same, so that's good. Right, so now all the voltages are in order. So fact was, data books here, and a collection of transistors. I went through everything I have, and I may have some exotic ones. I'll check that later. So fact is that this transistor was faulty. I think the collector was completely dead, so it didn't pull it down, and that's the reason why we had about 8 volts or whatever rather than 2.8. Now the voltages are good. And BF324 is a VHF transistor. It's not actually a switching transistor, but if we go here and check our voltage levels, 2.8 is target, and that's 2.9. I can live with that. And at the bottom is the same. We still need to adjust the center because I messed around with that. But yeah, the only fault was this transistor. The good thing with Tektronix scopes, the transistors are in sockets, which is a good thing. It's a good thing and a bad thing. Sometimes the contacts are wearing out, and especially if you move it around. Okay, we still need to look after the scratchy pot and a couple of other things, but it's working. Very happy about that. FM VHF 450 megahertz. It doesn't say a lot. I think it's 30 volts, whatever. That's fine. Unless I find another one, I'll keep that for now. Shorten the pins a little bit and push it in. The good thing is you don't need to solder anything. Anyway, simple fix at the end, but a bit tricky because the circuitry was not so clear. Anyway, next time we know it, if the other one dies. You shouldn't always believe what the internet tells you. We're looking for this one. I was just looking for equivalence. Look at that, and it says 3646. It says SIN, that means NPN. Well, it won't work. Ah dear. Anyway, I'm happy with the BF324 at the moment. It still runs. I need to switch the light off, and then the noise is gone. Looks stable. We need to tackle the other issues. At least the channel is working again now. There was a reason why these scopes were so expensive. Everything was perfectly documented. There are errors in the drawing sometimes, or in the description, but probably because they changed something or whatever. For example, this manual says there is a notch here, but there is no notch on that pot. So whatever, either my pot is dead, has no notch anymore, or whatever. Anyway, every time I take a Tektronix manual or a Hewlett Packard manual or even a Marconi manual, it's just amazing. Just another reason why I like old quality and measurement gear. At some point you get it fixed. It's just a matter of time to get to the problem. Alright. We'll come back when we do the other stuff.